We're back to problem 3, and in part 1 we solved the problem. We created the linear program over here. We solved the program and we found that our solutions were going to be 12.5 and 30. Let's go ahead to the Data tab. Let's go to Solver. Here's our model. Make sure that our objective function is set correctly, R11. I hit Solve. And then we see that the values have been changed for I and G. This is where the algorithm does its work. I want the answer report and the sensitivity report to begin to answer questions B and C. Here's the answer report. The answer report tells me that the value of the decision variable I is 12.5. The decision variable G is 30. It also gives me information on the final value of the objective function, which is 10,875. And down here we see something about the constraints. You should have read that if a constraint is binding, that means the left-hand side is equal to the right-hand side, and there is no slack. If it is not binding, then the left-hand side is not equal to the right-hand side, and here's the amount of slack. So the 3,500 units in excess that are not used by the left-hand side are left over for this particular constraint. Here's another binding constraint. So the budget constraint and strategy 2 are binding, and the others are non-binding, and this tells us by how much. So if we look at our back at our problem, it asked what is the optimal solution. We found what the optimal solution was, 10,875. What are the number of shares of I and G? 12.5 for I, 30 shares of G. Notice how this came out as a fractional value. You may not be able to buy 12.5 shares. If it's a mutual fund, you can. If it were units of stock, you'd have to buy a complete unit of stock and the value that's related to that unit. So the next question is, what if you had an additional dollar of budget? In other words, we're going to expand our $10,000 budget to $10,001. Without resolving the problem, what's the new optimal solution and the shares of I and G? Well, if we look for the answer report, we see, the sensitivity report, we see that there is a shadow price associated with the value of the budget constraint. In other words, since we've used up all our budget, if we had one more unit of the right-hand side, 10,001, that would return 1.065. Why is that? Well, because we would buy a fractional amount of the decision variable I. Why? Well, because that's one we have left. That's one that we won't break the constraints over. We cannot buy an additional value any more than 30 units of G, so that is fixed. And the only place we can get any kind of return is in I, and of course that's 6.5%. So $1 returns 6.5 cents essentially. So if we go back to our problem, the solution then, we can cut these reports out and paste them here, and we can see that the value of an additional share of I is going to change our objective function to this value here. Why? Well, because we purchase $1 buys how much of a share of I? Well, it buys 0.0005, 1/200ths of a share. Well, because the cost of a share of I is 200, and we have $1, so we purchase that much. And that's That gives us the new value of I because we purchased a hundredth or 1/200th of it, and it increases our objective function by 6.5 cents. So this is how we use sensitivity analysis in our modeling for linear programming. A very useful technique that tells us what the marginal value is of an additional unit of right-hand side. And of course, the only place where we can get additional value is where we have slack in some particular constraint, and that was in I. All right, that's the end of part 2, problem 3 in Mod 6.